Hello everyone, welcome back to my channel. Today I'm going to be focusing on the OSI reference model. So basically there are two models that have been devised to define computer network operations. The first one is the OSI reference model, or the open system interconnection, which is our focus on this lecture. And the second one is the TCP/IP protocol suite, which I'm going to be discussing later on. So let's directly jump into the fundamental concepts on the OSI reference model. So the OSI reference model was established in 1970s by the International Organization for Standards, which is the ISO. An OSI model defines how to facilitate communication between different systems without requiring change to the logic of the underlying software and hardware. So you can see that different systems without requiring change, because in computer networks, as you know, there are different network devices with different software and hardware architectures and different functionalities, right? So these different systems can communicate each other by using the OSI reference model as a reference without the requirement of changing the logic of any software, hardware, or functionality of the devices involved in that computer network. This is best explained by an example. If you have, for example, two computer systems in a computer network with different operating system softwares, one having, let's say, Windows operating system and the other having Linux operating system, then these two computer systems with different operating systems can actually communicate each other regardless of their differences by using the OSI reference model, right? So generally the OSI reference model describes the entire process of transmitting data from one device to another, and the OSI model is actually important or used as a reference tool to understand communication process, and it divides the communication process into 7 layers. The OSI reference model is a 7-layer conceptual model, and it describes standards for intercomputer communication. In other words, how does data gets from one device to another in a computer network? This is exactly what the OSI reference model attempts to figure out, right? So the OSI reference model is a stack of 7 layers, starting from the application layer, then presentation, session, transport, network, data link, and physical. So if you go from the uppermost layer, the application layer, all the way down to the physical layer, we have layer 7, layer 6, up to layer 1, right? So this OSI reference model is stacked in this particular order, and the order is actually very important, right? So I'm going to tell you how you can remember the orders of this OSI 7 layers. But for now, to understand the 7 layers of the OSI reference model, let's take an example. If we have two computers, node A and node B, with two intermediate devices, let's say switches or routers or whatsoever it is, and if node A wants to transfer data to node B, before the physical data appears on the transmission medium or on the cable, then it's generated on the application layer of node A and go all the way down to the physical layer. And the physical layer of node A gets the bits physically onto the cable and transfers to the second node, which is node B. So the physical layer of node B receives the data and gets them all the way up to the application layer. So this way all the layers or the data actually crosses all the layers of the 7 OSI reference model by appending different important informations in each layer. And each layer in OSI reference model can actually be referred to as a package of protocols. And in particular, the uppermost layers, the application layer, presentation layer, session layer, and transport layer, are actually peer-to-peer layers, or the protocols, package of protocols that are included in the uppermost layers are actually a peer-to-peer protocols, right? Because the communication is process-to-process communication. That means the application layer of the first device or node A communicates or interacts with the application layer of node B, and presentation layer with the presentation layer of node B, session layer of node A with session layer of node B, and so on, right? There is no application layer, for example, in the intermediate nodes. So the order of this stack of 7 layers in the sending node is from layer 7 to layer 1, and in the receiving node it's from layer 1 to layer 7, right? Layer 7. And you can see that the intermediate nodes implements the functionality of layer 1 up to 3, the physical layer, data link layer, and network layer, because these intermediate nodes are actually implemented in network, data link, and physical layers. For example, the routers are in network layer, switches are implemented in data link layer, transmission mediums like cables, network interface cards, and others are actually in the physical layer. So they are implemented by the three lowermost layers: network layer, data link layer, and physical layer. And you can see from the figure that network, data link, and physical layers are responsible for device to device interaction, right? Whereas the upper most layers, the application, presentation, and session, including transport layer, are actually responsible for process to process interaction. Now I'm going to tell you an acrostic aid to memory or mnemonics to remember the exact orders of the OSI layers. So starting from the uppermost layer, the application layer, we have all people seem to need data processing. So with this sentence, we have all people seem to need data processing. You can remember the orders of the OSI reference model starting from layer 7. So you can see that A is for application, P is for presentation, S is for session, T for transport, N for network, D for data link, P for physical. So all people seem to need data processing. Now let's see the broad overview on the services provided by the 7 OSI reference model layers. So with the topmost layer, which is the application layer, the application layer is where the user interacts with the application, and it's where we can find network applications like mail, web, file transfer, management with SNMP, remote connections with telnet, and so on, right? So the application layer services are actually provided by sets of protocols like mail by SMTP, web by HTTP, file transfer by FTP, management by SNMP, remote connections by telnet, and so on, right? So for example, HTTP is used with web browsers like Chrome, Firefox, or Internet Explorer while surfing the internet, right? And you can see here that the datagrams that are in the application layer are called upper layer data. The presentation layer, or the 6th layer in the OSI reference model, provides context for communication between layers, and it deals all about the format of the information, right? It may be in the form of ASCII, it may be in the form of ABCD, and the form with which the data is presented is dealt with the presentation layer. And encryption, decryption is one of the services provided by the presentation layer. Whenever there is a confidential information that we want to transfer, for example, while shopping online, everything we enter into the internet is confidential, right? So in this case, encryption, or converting the form of the information into other forms so that attackers can get it, is important, right? So this way, encryption and decryption is one of the responsibilities of the presentation layer. And the other one is compression. Most of the time when we need actually we need high data transfer rate and lower space requirement, right? In this case, we need to compress some information, right? So the presentation layer deals with the compression of data. And the datagrams that are in the presentation layer are still called upper layer data, And the second layer, the third layer in the OSI reference model, is the session layer. The session layer controls dialogues between computers, and it controls duplexing, termination, and restarts. So all it does is it controls the session between different dialogues of computers, right? It may be termination of sessions, it may be starting of sessions, it may be restarting terminated session already, and it makes sure there is a duplex communication in both sides. And the datagrams that are in the session layer are still called upper layer data. So you can see that the datagrams in the application layer, presentation layer, and session layer are called upper layer data. There is no specific name for them, right? And layer 4 is transport layer, which is actually very important layer, and it provides transparent transfer of data, and it actually uses TCP and UDP for transparent transfer of data. And TCP, actually transfer control protocol, is used for applications that need reliable connection or reliable communication, and UDP is used for some applications that are not that sensitive for packet loss, right? For example, for the application of voice communication, voice is sensitive for delays and packet loss, right? So in this case, for voice communication, UDP or user datagram protocol is actually suitable. But when there is sensitivity in packet loss, then TCP is the best application or the best protocol in the transport layer. And the other service provided by the transport layer is in connection. The other one is reliability, flow control, remote connections. And what's important here is datagrams in the transport layer are called segments. So there are no more upper layer data. So after the application layer, presentation layer, and session layer appends their own information, layer information, the upper layer data gets into transport layer and becomes segments. It's called segments. And the third layer is the network layer, and it's where routers exist, right? It provides connection between hosts in different networks. It's important that it provides connection between hosts in different networks, not just same networks. If the hosts are in the same network, it's just the data link layer that's responsible. But the network layer provides connection between hosts in different networks. And in the network layer, there are IP version 4 and IP version 6, IPv4 and IPv6. Actually, they are not important here, but since network layer is responsible for two important things, one is addressing and the other one is routing. So for addressing, this IP version 4 and version 6 address are actually very important. And the other responsibility or service provided by network is routing of packets. And the datagrams that were segments in transport layer are called packets here in the network layer. And the second layer is the data link layer. The data link layer provides connection between hosts in same networks. Same networks, unlike that of the network layer, which provides connection between hosts in different networks. It provides connection between hosts in same networks, and it's exactly where switches appear, right? And in data link layer, you can see that the famous IEEE LAN standard, which is Ethernet, and data link layer is where the physical addresses or MAC addresses are actually dealt with, right? And the datagrams in the data link layer are called frames. And the last layer or layer 1 in the OSI reference model is the physical layer, and you can think of the physical layer as you can see everything as you can feel and touch, right? So it describes electrical and physical specifications for devices like cables, connectors, hubs, repeaters, and you can see different connectors like SC connectors, MT connectors, ST connectors for optical fiber communications, and RJ45 and other connectors. are actually in the physical layer, and you can actually think of this layer as you can feel and touch everything. And the data here in the physical layer are called just bits, right? Bits. So thank you very much for watching. If you have any questions and comments, let me know in the comment section down below.